Hello students, I am Shubhashish. Today we are going to learn the applications of ratios. Ratios help us compare two or more things. For example, if you have 4 red pencils and 6 blue pencils, the ratio of red pencils to blue pencils is 4:6. This means for every 4 red pencils, you have 6 blue pencils. You can also use ratios to compare things like money, time, or distances. Imagine two friends are sharing a bag of marbles. One friend gets 5 marbles and the other gets 8 marbles. The ratio of marbles they have is 5:8. Ratios help us compare the amount of one thing to the amount of another. For example, if a recipe calls for 2 cups of flour for every 3 cups of sugar, the ratio of flour to sugar is 2:3. Ratios are useful in many situations, like when you divide things fairly or figure out proportions. Learning outcomes. After the completion of this lesson, you will be able to learn how to compare quantities using ratios, simplify ratios and express them in the simplest form, learn how to find equivalent ratios, solve problems involving ratios and proportions, apply the unitary method to solve problems. Keywords from this lesson are ratio, antecedent, consequent, simplest form, equivalent ratios, proportion, continued proportion, unitary method. Ratio. A ratio is a way to compare two or more quantities of the same kind by division. It shows how much of one quantity exists relative to another. The ratio is usually represented by a colon. The ratio A:B is read as A:B. For example, if we say that the ratio of apples to oranges is 3:5, it means that for every 3 apples, there are 5 oranges. Terms of a ratio. If the ratio A:B, the two quantities are called the terms of the ratio. The first term A is called the antecedent. The second term B is called the consequent. Notation of ratios. Ratios can be written in 3 common ways. A:B colon form, A to B word form, a by b fraction form. Now we will solve some examples. Example 1. What is the ratio of ₹100 and ₹10? Express your answer in the simplest form. Solution. The given ratio is 100:10. As the ratio 100:10 can also be written as 100/10. Therefore, 100:10 is equal to 100/10. Which is equal to 10/1. That is equal to 10:1. Thus, 100:10 in its simplest form is 10:1. Example 2. Divide 108 in two parts in the ratio 4:5. Solution. The given ratio is 4:5. Let the two parts be 4x and 5x. Thus we have to divide 108 into two parts, 4x and 5x. Therefore, 4x plus 5x is equal to 108. 9x is equal to 108. X equals to 108/9. X equals to 12. Therefore, the first part, 4x, is equal to 4 into 12. Equals to 48. Second part, 5x, equals to 5 into 12, equals to 60. Example 3. The speed of a garden snail is 50 meters per hour and that of the cheetah is 120 km per hour. Find the ratio of their speeds. Solution. To find the ratio of the speeds of the garden snail and the cheetah, we first need to express their speeds in the same unit. Given. The speed of the garden snail is 50 meters per hour. The speed of the cheetah is 120 kilometers per hour. We know that 1 kilometer is equal to 1000 meters. Let's convert the cheetah speed from kilometers per hour to meters per hour. 120 km per hour is equal to 120 into 1000 meter per hour is equal to 1,20,000 meter per hour. Now we have speed of garden snail equals to 50 meter per hour. Speed of cheetah equals to 1,20,000 meter per hour. The ratio of their speeds is ratio equals to 50 meter per hour by 1,20,000 meter per hour equals to 50 by 1,20,000. We get 1 by 2,400. So the ratio of the garden snail speed to the cheetah speed is 1:2,400. Example 4. If 4x plus 5 is to 3x plus 11 is equal to 13:17, find the value of x. Solution. Given 4x plus 5 is to 3x plus 11 equals to 13 is to 17. Now write this in fractional form. 4x plus 5 by 3x plus 11 equals to 13 by 17. Do cross multiplication and solve for x. 17 of 4x plus 5 equals to 13 of 3x plus 11. 17 into 4 is 68x plus 17 into 5 is 85 equals to 13 into 3x is 39x plus 13 into 11 is 143. Now take all like terms to one side, that is, all x terms to one side. 68x minus 39x equals to 143 minus 85. 29x is equal to 58. X equals to 58 by 29 equals to 2. Equivalent ratios. A ratio obtained by multiplying or dividing the numerator and denominator of a given ratio by the same number is called an equivalent ratio. For example, consider the ratio 8 is to 6. 8 by 6 is equal to 8 into 2 by 6 into 2 equals to 16 by 12. 8 by 6 equals to 8 into 3 by 6 into 3 equals to 24 by 18. And so on. 8 by 6 equals to 8 divided by 2 by 6 divided by 2 equals to 4 by 3. Thus, 16 by 12, 24 by 18, 32 by 24, 4 by 3, etc. are ratio equivalent to the ratio 8 by 6. Now we will solve few problems. Example 1. Find two equivalent ratios of 6 is to 15. Solution. Given 6 is to 15. 6 by 15 equals to 6 into 2 by 15 into 2 equals to 12 by 30. 6 by 15 equals to 6 into 3 by 15 into 3 equals to 18 by 45. So 12 by 30, 18 by 45 are equivalent ratio of 6 by 15. Hence, 12 is to 30, 18 is to 45 are equivalent ratios of 6 is to 15. Proportions. In proportions, we compare two ratios to see if they are equal. For example, if we have a photo that is 6 cm wide and 9 cm high, we can create a ratio of width to height, 6 by 9. Now let's say we want to enlarge the photo and we know the new width will be 12 cm, but we don't know the new height. We can set up a second ratio using the new width and the unknown height, 12 by x. In a proportion, the two ratios must be equal. So we write 6 by 9 equals to 12 by x. This means the ratio of the original width to height, 6 is to 9, is the same as the ratio of the new width to the unknown height, 12 is to x. Proportions are helpful because they let us find missing values when we know some of the numbers but not at all. A proportion is an equation that expresses the equality of two ratios. In other words, a proportion states that two ratios are equivalent or equal to each other. It is often used to solve problems where one quantity is unknown but the ratio between quantities remains consistent. Four numbers A, B, C, D are said to be in proportion if the ratio of the first two is equal to the ratio of the last two. That is, A is to B equals to C is to D. If A, B, C, D are in proportion, then we write A is to B is to C is to D, where the four quantities A, B, C and D are called first, second, third and fourth terms respectively. The first and fourth terms are known as extreme terms or extremes. The second and third terms are known as middle terms or means. That is, A by B equals to C by D. Therefore, AD equals to BC. Thus, the product of means is equal to the product of the extremes. Continued proportion. Three numbers A, B, C are said to be in continued proportion if A, B, B, C are in proportion. Thus, if A, B, C are in continued proportion, then A, B, B, C are in proportion. That is, A is to, B is to, B is to C. Product of extremes equals to product of means. A into C equals to B into B. AC equals to B square. B square equals to AC. Now we will solve some examples. Example 1. If 3 is to x is to 12 is to 20, find the value of x. Solution. Given 3 is to x is to 12 is to 20. 3, x, 12, 20 are in proportion. So product of extremes is equal to product of means. Three into 20 equals to x into 12. 60 equals to 12x. Now we need to find the value of x, so we will divide both sides by 12. Sixty by 12 equals to 12x by 12. 5 equals to x. X equals to 5. Example 2. Are 36, 49, 6, 7 in proportion? Solution. Given. To be in proportion, product of extremes equals to product of means. Product of extremes. 36 into 7 is equal to 252. Product of means is equal to 49 into 6 equals to 294. Clearly we can see that product of extremes not equal to product of means. Hence 36, 49, 6, 7 are not in proportion. Example 3. A man whose weight is 90 kgs weighs 15 kg on the moon. What will be the weight of a man on the moon whose weight is 60 kg? Solution. Given 90 kgs man weight on the moon is equal to 15 kg. Let 60 kgs man weight on the moon be is equal to x kg. Now take ratios of earth weight to moon weight. That is, earth weight is to moon weight. "90 is to 60 is to 15 is to x. "90 by 60 equals to 15 by x. By cross multiplication, 90x is equal to 15 into 60. 90x equals to 900. X equals to 900 by 90. X equals to 10. Therefore, 10 kg will be the weight of a man on the moon whose weight is 60 kg on Earth. Example 4. Are 4, 12, 36 in continued proportion? Solution. Given 4, 12 and 36. We know three numbers A, B, C are in continued proportion if A, B, B, C are in proportion. Therefore, 4, 12, 36 will be in continued proportion if 4, 12, 12, 36 are in proportion. To be in proportion, product of means is equal to product of extremes. Product of means is equal to 12 into 12 equals to 144. Product of extremes equals to 4 into 36 equals to 144. Therefore, product of means is equal to product of extremes. Hence, 4, 12, 12, 36 are in proportion. So, 4, 12, 36 are in continued proportion. Unitary method. The unitary method is a technique used to solve problems where we find the value of a single unit and then scale it up to find the value of multiple units. It is a method in which we first find the value of one unit article from the value of the given number of articles, and then we use it to find the value of required number of articles. Value of one article equals to value of the given number of articles by number of articles. And value of required number of articles is equal to value of one article into required number of articles. Now we will solve some examples. Example 1. If 6 bowls cost Rs 96, what will be the cost of 15 such bowls? Solution. Given cost of 6 bowls equals to Rs 96. Therefore, cost of one bowl equals to 96 by 6 equals to Rs 16. Hence, cost of 15 such bowls is equal to Rs 16 into 15 equals to Rs 240. Example 2. What is the cost of 9 bananas if the cost of a dozen bananas is Rs 48? Solution. Given dozen bananas cost is equal to Rs 48. 1 dozen is equal to 12 units. So cost of 1 banana is equal to 48 by 12 is equal to 4 rupees. Hence 1 banana cost is rupees 4. Therefore the cost of 9 bananas is equal to 9 into 4, which is equal to 36 rupees. Points to remember. A ratio compares two or more quantities and is written using a colon or fraction. The first term of a ratio is called the antecedent and the second term is called the consequent. Ratios can be simplified by dividing both terms by the same number. Equivalent ratios can be found by multiplying or dividing both terms of the ratio by the same number. A proportion shows that two ratios are equal and you can solve them by cross-multiplying. The unitary method is a technique used to solve problems where we find the value of a single unit and then scale it to find the value of multiple units. Thanks for watching.